So as I've mentioned before, we're prepping for calculus here. And so average rate of change is the first way that we can think about computing a slope for a function that's not linear. But what you're going to see in pre-calculus and calculus is the average rate of change written a different way, called the difference quotient. Don't let it scare you. It's literally the exact same thing as average rate of change. We just have to change a little bit of the way we think about the graph. So let me explain what this graph is talking about. Just want you to focus on this point to begin with. Imagine we pick any x on the x-axis, and it has some y value, f of x. That's our function notation. So rather than calling it x1, we're just calling it x. Then we decide that we're going to choose some distance to move, some h distance. And so we're like, we just want to use an arbitrary number to represent that. So if I add h to x, I end up somewhere over here at the x value of x plus h. H is just the distance between them. If I take a look at the graph there, this point has a y value. Its y value is represented in function form as f of x plus h, where h is just some distance away we've moved from x. So now let's imagine I want to find the slope between these 2 points, and I just connect them again with a straight line. This average rate of change is just the slope formula again. So I want you to see how this average rate of change formula that we've been working with changes into a difference quotient formula. They are different. You have to learn the 2 forms of it, but they're measuring the same thing. So here's your familiar average rate of change, y2 minus y1 over x2 minus x1. I'm going to change this to function notation. So here's my second point. Its y value is f of x plus h. I put that there. Here's my first point. Its y value is f of x. I put that there. My x2, here's my second point. It's x plus some distance h. I put the x plus h here. Minus is part of the average rate of change formula, x1, my original x. Now what you might notice now in the denominator is that this x and this negative x cancel, so this simplifies to the distance h in the denominator, some movement away from x, and f of x plus h minus f of x. This is a major calculus formula. When you get there, that's what you're going to be using. So I want to show you 2 different examples. One where you don't need the difference quotient, but it's helpful to practice working it out, and then one where you do. So we've already talked about these linear functions, right? Average rate of change is the same thing as slope. So here we have, again, a linear function, 3x minus 2. You're asked to find the difference quotient. Well, the difference quotient is the slope. That's all it is. This is a linear function, mx plus b. The slope is 3. The difference quotient is 3. You're done. But to practice the formula, since it's a new kind of clunky formula, it's nice to know the answer so that when we go to practice it, we can see what's happening here. So the first thing you're going to do is compute this new guy, f of x plus h. It's a little weird, but what this means is that you're going to input, you're going to substitute x plus h where x is. So here's x, 3x minus 2. So we're going to do 3x plus h minus 2. I'm going to have to distribute this 3, which gives me 3x plus 3h minus 2. That's just the first little step getting ready for the difference quotient. Now I'm going to take f of x plus h and f of x and plug them into my formula here. I'm highlighting this negative because it's very important. It's going to cause you to get answers right or wrong, whether or not you remember the formula had a negative in it. So our f of x plus h, we said, was 3x plus 3h minus 2. Here it is. This negative is part of the formula. Notice I'm using parentheses here. This is the original function, 3x minus 2. I'm going to distribute the negative because this is a binomial, and that's going to change to negative 3x plus 2. Something magical is about to happen. Notice this 3x and this negative 3x cancel. Notice this negative 2 and this positive 2 cancel. And my numerator reduces to 3h. My denominator remains h. But then notice that this h in the numerator cancels with this h in the denominator. And not surprisingly, we knew the slope was 3. This was a linear function. We got the difference quotient. For this particular function, the slope is always 3. No matter what x you pick, no matter what h you pick, it's always 3 because it's a line. So the difference quotient formula isn't really that useful for lines. We had it up here. What it is really useful for is when a function is not linear, and so that's what we're going to look at next. In this class, we're not going any bigger than a quadratic for practice, but eventually as you move into pre-calculus and calculus, you're going to be able to do this for all different kinds of functions. So lines and parabolas are all we're going to really be focusing on here, but it is useful for everything.